Congratulations on getting through chapter 9. The work with quadratics is pretty intense, and I know we spent a good chunk of time both before and after we closed school covering that. So I think you're going to really like knowing that as we get into move on to geometry or algebra 2. So good on you for that. We're going to start in on what will eventually be the last topic of the year, believe it or not. We're just going to look at a couple of special kinds of functions. Today, of course, is the square root function. And then I'm going to show you a couple of things we can do with functions that you might not have expected. And my goal here is to try to give you just a foundation to build on for your future work in math, whether it is geometry or algebra 2. Eventually, I'll be doing that same work. So let's start with this concept of a square root function. You can see the notation here, f of x equals the square root of x. I'm going to switch over and show you what the graph of this function looks like on Desmos here. And what you'll notice here is that it starts at 0, 0, which makes that kind of a nice reference point for us. But also that it doesn't continue forever and ever. It sort of stops. It goes forever to the right, but then it stops to the left. And so there's something interesting about the square root function, and I want to walk you through what it looks like, how we can think about graphing it, and so on. So what I'd like you to do on your paper is set up a graph. And I think what we're going to do, I think I'll move this over here, actually. Okay. And we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. 1, 2, 3, 6. And I'll go down here 1, 2, 3, 4, 5, 6, but you're going to see in a few minutes we're not actually going to be ever down there. Then what I'd like to do is over here, let's make a t-chart again. I haven't done this so long. Remember doing this? Where we pick different values for x and figure out what that is for y. So let me start with a couple of the more obvious x values, and that's going to be 0 and 1. But we're going to stop right there, and then I have to think about this a little bit because it gets a little bit tricky after that. So remember, think about what a square root is. A square root of a number is some other number you multiply by itself to get the original number. So the question is, over here now, right here. What do I multiply by itself to get 0? And the answer is 0. Okay, so that's something. So I'm going to go ahead and put a point here, 0, 0. Again, we've done this before, right? We've graphed lots of these functions in this way. My goal is to slowly show you how to do this, and then you'll be really quick at it. Okay, so what number now do we multiply by itself to equal 1? I hope you quickly recognize that that would be 1. So 0, 0, 1, 1. And frankly, at this point, there's nothing terribly interesting about this graph. 0, 0, 1, 1, we've done that before. But the next point I'm going to pick is going to be intriguing to me because I don't think I want to put 2 here. Oh, hang on. I don't think I want to put a 2 here. Can you think about why that would be? Like, what is the square root of 2? I don't know what it is. I mean, I could type it in a calculator and it'll give me an answer that's kind of close to it, but I don't easily know the square root of 2. So I'm not going to put 2 there, and I'm not going to put 3 there. But I am going to put 4 there. Why would I do that? Because 4 has a square root, right? I know a number that when multiplied by itself, it makes 4, and that's 2. So I can go to the point 1, 2, 3, 4, 2, and you can ever so slightly begin to see the curve here that wasn't so obvious with the first 2 numbers. So now the question is, what do I put next here for x? I don't think I want to put 5 or 6 or 7. So let's think here. What's the next number that we generally know the square root of? Did you say 9? That's what I'm thinking, 9. And I like 9 because the square root of 9 is 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Get a point right up here. Now already I believe I can sketch this graph. I think I can graph it from here. It's going to curve up. It's going to start to look like that. And if I flip back to Desmos, you'll see that that generally shows the same pattern. Here is 4, 2 right there. I'm going to get to 4, 2. And there's 9, 3 right here. Really close to 9, 3. But what's interesting is I made my graph big enough, 10, 11, 12, 13, 14, 15. I can actually go out to 16. Because 16 also has a square root that I happen to know, and that's 4. So there's pretty nice value in knowing these square roots right here. Because now I can add this to the list, 1, 2, 3, 4, 16 is over here, and the graph will just kind of continue on like that. So it's a bit of an odd graph, don't you think? For one thing, it doesn't do anything over here, apparently, and that's odd, but it also doesn't do anything down there, and that's kind of odd. So let's think for a second why it doesn't do anything over here. So over here, in this area here, x is negative. So let's go ahead and try it next. Let's try -4 here. What would the square root of -4 be? If you have your calculator, like I do right here, try it. I'll do the square root of -4, and I'll put this on the screen so you can see it. Just 1 second. Square root of -4. So I'm going to take this off for just 1 second. Whoops, 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 whoops. And show you this. See what this says? Error, non-real answer. If I go to the problem, I try to take the square root of -4, it doesn't like it. Why is that? Because, if I may go back to my graph here, there's no number here that when I square it equals -4. You might think, oh, -2, right? No. -2 times -2 makes +4. That doesn't work at all. There's no number that we know that we can square to make -4. So there's nothing over here, not there at all. Therefore, what we do is we talk about the domain of the square root function as x being greater than or equal to 0. Now I want you to think about that. Domain is a set of all x values that I'm allowed to legally plug in to that function. I can take the square root of 0. I can take the square root of any positive number I want, but I can't take the square root of a negative number. So my domain is restricted to all, we say non-negative, but all x is greater than or equal to 0. So therefore, what do you think the range is going to be? Well, the range is all the y values. And I want you to really make sure you understand this, because I've had students at much higher courses than Algebra 1 struggle to understand this concept. The square root of any number, by definition, the square root of any number is positive, or 0 if it's 0. So I would never say the square root of 9 is -3. I would never say that. Now, I understand that when we solve a problem like x squared equals 9, we take the square root of both sides, we get x equals plus or minus 3. So you're thinking, isn't that what the square root is? No, the square root of 9 is just 3. When we solve an equation, which we're not doing here, when we solve an equation by taking a square root, we then take the positive and negative version of that square root, which is positive, as our possible answers. So the range is all y is greater than 0. Okay. So that's great. But I am now curious about what happens if I do this. If I put a number outside of the radical, outside of the square root, and add it to my function. So I'm going to go back, and now you've seen me do this before. I think some of you know exactly what I'm going to do here. I'm going to go here, and I'm going to begin to add and subtract things to my graph. In fact, I think what I'm going to do is I'll go like that, and I'll go y equals square root x, and I'll go out here and go plus 3. See what happened? I put a plus 3 outside of the radical, and that graph moved up 3 units. What do you think happens if I go plus 6? It went up 6 units. Well, what if I go minus 4? What do you think? Should be exactly as we predicted. That as long as you have a number that is outside of the radical, plus 3, plus 6, minus 4, then the effect of that number is going to be to shift the graph up if it's positive or down if it's negative. So we can look at a function now, maybe something like this. Y equals the square root of x plus 5. And we don't have to do a t-table anymore. We can simply take that graph and think, okay, I used to start at 0, 0. Remember, I go back here, 0, 0 was my starting value. Now that 0, 0 is going to shift it up 5 units. 1, 2, 3, 4, 5. So I'm going to put my first dot right there. And then from that point, that becomes my new origin. Then when I went to 1, I went up 1. I went to 4, I went up 2. The graph just gets shifted up 5 units. So right here, this means shift up or down C. That's not very good C, is it? And I'll put a plus or minus in there. So anything that lives outside of the square root moves the graph up or down. Okay, great. You know where I'm going now, don't you? Y equals the square root of x plus b, plus or minus b. So what does it look like when you go inside? Well, let's go back to Desmos and take a look at it. I'm going to take this away. I think what I'm going to try to do is get inside here, and we do the same thing. Let's just go plus 3 again, shall we? So I'm going to be in here, plus 3. So remember, before the plus 3 moved me up. Well, what's going to happen to plus 3 now? Any guesses? Is that what you anticipated? Now, are you sitting there thinking, I thought it was going to go to the right because it's +3. And maybe you hear my voice saying, well, of course you hear my voice saying, because I'm about to say it. X's are opposite, right? Every time we had a +3 of the X's, I always went the opposite direction. So what might I don't know, X plus 5 look like? It moves 5 to the right, to the left. But we think, well, how do we get it to move to the right? We just move the minus, put a minus in there. So the shift in the X direction is opposite. Well, let me make that really clear here. So this shifts left if it's plus, or right if it's minus B units. So those two things, the number on the outside or the number on the inside, now simply take the same basic shape of the square root. And by basic shape, just go back to this real quick. By basic shape, I mean this basic shape right here. 0, 0, 1, 1, 4, 2, 9, 3. That same shape just moves up. It's sort of like me moving this around. It just moves it up and down or right and left. So to wrap up, I have a little practice problem for you to try. See what you think. Would you be able to graph, I'm talking graph here, not just talk about stuff, y equals the square root x plus 2 minus 4. So I'm going to give you a second to copy that function down. Put my graph out here, and I'm just going to put a lot of marks here. I don't know. I don't know exactly where I'm going to end up. But let's think about this. We know we have this general shape of a square root that looks like that. It starts at a point 0, 0. I made a little face there. This minus 4 looks like it's going to drop me down to this point right here, right? But then there's a plus 2 in here, which is going to move me back to. So this point, which I like to call the vertex, I know that's usually associated with a quadratic function, but I like to call it a vertex. Your book will call it a minimum point. And I think you'll see why in just a second. Our minimum point or our vertex is minus 2, minus 4. Okay, so that's like our origin. I might just put it out here, parentheses, like an origin. So then what I'm going to do is I'm going to go over 1, up 1. Because I know that from the origin, when x is 1, square root of 1, y is 1. I'm going to go over 1, 2, 3, 4, and go up 2. And I'll go up 4, 5, 6, 7, 8, 9. I'll go 1, 2, 3. So everything is relative to this origin or vertex or minimum point. So I'm still using these relationships right here. This 0, 0, 1, 1, 4, 2, 9, 3. I'm still using those, but now I'm putting them over there. So I want to see how I did here. Minus 2, minus 4. I can pick some other points as well. Let's go back to Desmos and take a quick glance at this function. So I'm going to go, it was x plus 2, right? And then minus 4 on the outside. And look, the vertex point is in fact negative 2, negative 4. And if I go over 1 and up 1, I'm at this point here, negative 1, negative 3. And if I go over 1, 2, 3, 4, I'm at this point right here, which is a nice one to graph, and so on. So in the end, we can actually, look, in the matter of like 15 minutes, we get to the point where we could graph that function. That's pretty awesome, guys, especially doing it remote. So once you play around this a little bit this week, you have 3 options for your homework assignment. Option 1 is your book, page 415, 5 through 8, 22 through 28, and then 40. Option 2 is the worksheet 6.8, and that's available on the website. You can download it if you want. And option 3 is a CUDA worksheet on radical functions. You're only going to do questions 1, 2, 5 through 8, and 11. So pick one of those, get it done. As soon as you get it done, turn it into me, and you'll be good for the week. With that, I will sign off. I wish you well. Be safe. Be healthy. See you next Monday.